Welcome to this video about the expansion of the octet. Let's get going. All right, what do we mean by the octet in the first place? Well, the octet is the idea that in covalent bonding, there are 8 electrons around the central atom. Okay, now let's see what that means. Well, if you take something like water, let's have a look at water. Water would look like this. 1, 2, they're the lone pairs for water, or the oxygen. And there we go. Okay, and if you look at this molecule here, or this center, there are 8 electrons around the oxygen. Okay, and this is what we call the octet rule. Okay, and we used it in 4-5 quite a lot. Okay, and we managed to count up to 8. Okay, all right. Now, interestingly, there are atoms which do not obey the octet rule. Okay, there are atoms which do not obey the octet rule. Okay, having said that, period 2 atoms all obey the octet rule. We'll come to that in a minute, okay, why that is the case. Okay, but there's some atoms that don't obey this, and that's what we're looking at That's what we're looking at now. All right, so I think the first one to look at is phosphorus. So let's have a look at phosphorus. Okay, and the configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Okay, and obviously it must therefore be in period 3. Okay, so let's have a look at this. All right, now before we go on, these ones here, the inner electrons up until here, these are known as the inner electrons. I'm not interested in. Not interested. Okay, so we're just going to look at these guys here. All right, so let's draw my electrons in boxes. And there's one box. Oh, that's an awful box, isn't it? Let's try and draw that again. Okay, there's a box. There's another box. These are my electrons. All right, and now let's populate the boxes. Before we do that, this is the 3s, and these are the 3p. Okay, and populate the boxes. Let's use a nice bright color, nice this pink color. So there's 3s2, there are these two, and 3p3. Okay, so how many unpaired electrons does phosphorus have? Phosphorus has 3 unpaired electrons. Okay, and that means that implied by this is it can make 3 bonds. Okay, all right, and so let's draw it then. Well, let's do PCl3. Okay, PCl3 looks like this. Central phosphorus, and let's do. These are the 3s's, these two, and 1, 2, 3. Okay, and let's draw chlorine. 1, 2, 3. And with its electrons, there we go, this is the Lewis structure of PCl3. There we go. If I make a mistake, don't worry about it. Okay, and as we look here, if we look at this phosphorus, this does obey the octet rule. Okay, and why does it? Well, because it has 8 electrons around the P, the phosphorus. Okay, now that's interesting, and this is just really setting us up for the lesson. All right, but let's have a look at another situation. Now, to mess things up for us, as well as PCl3, this one, phosphorus also forms a PCl5 compound. Okay, and we've got to explain this using our model, don't we? Okay, so let's have a look at this. Okay, again, these are the 3s's. These are the 3p's. And now I'm going to draw the 3d's. Okay, now there's split that up into 3, 2, 3, 4, 5. Okay, and these are the 3 S's, these are the 3 P's, and these are the 3 D's. Now let's populate my electrons. 3s2, 3p3. Now in this format, obviously you can make 3 bonds because this is what we've done up here. But now I'm going to sneakily get rid of this electron here, very badly, by the way. All right, and I'm going to move it up to here. All right, this is known as promotion. This is promotion of an electron. Okay, now look, if we count the unpaired electrons now, there are 5. So this would imply phosphorus can make 5 bonds. Okay, now let's draw the phosphorus now, PCl5. Let's try and draw this guy. So we have P, let me see what I used before. Okay, 1, 2, 3, 4, 5. Okay, and now I've got to draw 5 chlorines around this. 1, 2, 3, 4, 5. Let's have my electrons there. Okay, and we draw these. Okay, trying to keep all my chlorine electrons nice. This is a nice way of practicing your Lewis structures. And there's PCl5. Now, if we look at PCl5 and we look at the... Ooh, that's awful. Let me get rid of that. If we look at the central phosphorus here, it's actually 10 electrons are around it. Now, this is more than the 8, isn't it? Okay, and period 3 can do this. Okay, now 8 was the octet rule, and now we've got 10 electrons. So we have expanded the octet. Okay. Now, there's a lovely example as well in sulfur, but this is the expansion of the octet in phosphorus. Let's have a look at sulfur. What can we do with sulfur? Sulfur, you can even do it more than phosphorus can. Right, first of all, sulfur is a yellow solid, so let me do it in yellow. And sulfur has a configuration of 1s2, 2s2, 2p6, 3s2, 3p4. Let's draw our electrons in sulfur. It's 1. These are going to be the 3s and the 3p. Again, I'm going to ignore these inner shells here. All right, so let's make this pretty. Okay, let's populate it. Oh, let me put these in first. These are the 3s. These are the 3p. Let's populate the electrons. 3s2, 3p1, 2, 3, 4. That's there. So looking at this, you'd imagine, well, there are 2 unpaired electrons. There's 2 unpaired electrons, and that would imply it can make 2 bonds. And it does. Sulfur forms 2 bonds in this guy, hydrogen sulfide. So let me put my 1, 2, 3, 4, 5, 6. These are the 6 sulfur electrons. There's 2 from the hydrogens, and there you go. And this is H2S. And H2S, as you can see, if you count around here, you have 8 electrons. So sulfur in H2S obeys the octet rule. Okay, it obeys it. Okay, well, that's fine. That's not what we're here for, is it? So let's do it again. These are the 3s. I don't know why I'm doing my 3s so big. They don't have to be big. 3p and 3d. And we're going to expand the octet here. Okay, let's make it pretty. 3s, 3p, 3d. 2 electrons there, 1 there, 1 there, 1 there. Again, that's the ground state of sulfur, isn't it? I'm going to get rid of one of those electrons and put it here. I'm also going to get rid of, oh, there you go. Now let's leave it at that. So now it's got 4. It now has 4 unpaired electrons. And what does that imply? Well, that implies it can now make 4 bonds. And we see this 4 bonds in sulfur dioxide. Okay, so let's very quickly draw sulfur dioxide. Sulfur, it has 1, 2. It's going to form a double bond there and a double bond there. Oh, that's not good. That last one's not good. Let's A bit further down, I'm going to draw there and there. Let's use white. What the hell? There's an oxygen there and an oxygen there. And what were oxygen? Oxygen with these green things. Okay. There. And if we were to draw, the structural formula, it would look like that. That's sulfur dioxide. All right. Now, if you look closely at the sulfur, it has 10 electrons around the sulfur. And so what have we done? We have expanded the octet again. Okay, so here we didn't expand it, H2S, but here we did. 4 bonds around the sulfur. And sulfur can actually go one step further, so let's do the further step. Okay, these are the 3s. I'm going to draw this one bigger because otherwise it's quite hard to delete my electrons. Okay, so there's 3 there. 2, 3, 4, 5. These are the 3s. These are the 3p. These are the 3d. Let's populate them. 1, 2, 1, 2, 3, 4. Okay, that's how sulfur is originally. Okay, I can get rid of that last one and promote it to here. Can form 4 bonds now. And now, if you look carefully, I'm going to get rid of them there. It's going to put one back there. I'm going to put one over here. So now it has 6 unpaired electrons. 6 unpaired electrons. And now that would imply it can form 6 bonds. And we see that in sulfur trioxide, which would look like this. It forms 6 bonds. All right. Now, very quickly, I'll draw the sulfur. There's a double bond there, so I'm going to put 2 there. Double bond here, and a double bond here. Let's put my oxygens in green. There's going to be 1 there, 1 there, and 1 there. Let's use white electrons because they stand out nicely. Double bond there, and I've got to draw my oxygen electrons. There you go. Okay, and if you count around here, if I've done it right anyway, if you count around here, it actually has 12 electrons around the sulfur. And so what we have done now is we have extended the octet to 12. Okay, I hope that makes sense. Now, interestingly, up above right at the start, I said period 2 cannot expand. This shouldn't say extend, should it? It should say expand. The octet has been expanded, not extended. All right, so period 2 cannot expand the octet. Okay, and the reason for that is, well, because there's no 2d orbitals. In the second quantum shell, the only orbitals available are the s orbitals and the p orbitals. So there's nothing to expand into. There's nothing here. So that's why period 2 cannot expand the octet, but period 3 can expand the octet. So nitrogen can't do it. It's in period 2. Oxygen can't do it. It's in period 2. If you're in period 2, you can't expand the octet. All right, but in period 3, you can expand the octet. Okay, I hope that makes sense, and let me post this now.